Welcome to the practice unit of our tutorial. In this unit, you have the opportunity to test the knowledge you have accumulated so far using a practice task. The basis of this task is a substation that has two identically built-up outgoing feeders, each with one device of the type 7SJ64. You are to parameterize the device of one outgoing feeder in DIGSI-4. Included in this is also a simple CFC function with whose help you can reset stored counter values by pressing a key. Then you will initialize the device and in the process transmit the newly created parameterization. In addition, you will read out process data and determine the fault location of a network fault. In order to be able to solve the individual tasks, you need a DIGSI-4 in any case, best of all in conjunction with SIEMENS 4. You can find trial versions of both software packages on this DVD. For working with this practice unit, we recommend two computers, one PC for the work with DIGSI-4 and SIEMENS 4, and another one for viewing this DVD. That way, you can easily configure and parameterize while you get information on tasks and solution hints. You can do most of the tasks without a SIPROTEC-4 device. You only need one if you wish to go online. If you don't already have your own SIPROTEC-4 device, you can get a so-called demo box for a limited time period. In the demo box, a SIPROTEC-4 device including power supply is installed. The connections are conveniently located on the front side of the box, and beyond that, the demo box offers quite a bit of convenience. Talk to your Siemens partner if you're interested. The training process is easy. We have divided the complete task into individual partial tasks that you can work through one after the other. To navigate between the partial tasks, please use the usual topic and section control. First of all, try to solve a task independently. If you need a little help or would like to check your result, you can call up the solution path for each partial task in several steps. The best thing is to start DIGSI-4 right now and get going. We wish you every success. For the following task, the first thing you will need is a new project. Create one and give it the name Training. From the File menu, select the command New. DIGSI-4 opens the New Project dialog box. The topology of our training example is to consist of Station 1 with a 110 kV and a 20 kV voltage level each. The 20 kV voltage level initially has an outgoing feeder with the name Pontomac Street. Insert the required folders and name them. By default, the new project already has one folder. Rename it Station 1. With the right mouse button, click on the folder and select the folder entry from the pop-up menu. DIGSI-4 inserts another folder. Call the second folder 110 kV. Similarly, create a folder for the 20 kV level. With the right mouse button, click on the 20 kV folder and select the folder entry from the pop-up menu. DIGSI-4 inserts another folder. Call this folder Pontomac Street. In the folder called Pontomac Street, insert a device with the order number 7SJ64-12-4EB193RH71F and the firmware version V4.6. With the command Insert New Object, SIPROTEC Device, open the device catalog. Select the device type 7SJ64-1V4.6 and pull this from the catalog onto the Pontomex Street folder. DIGSI 4 displays the dialog box Properties SIPROTEC Device. In the MLFB tab, complete the device's order number. Click on OK. DIGSI 4 inserts a symbol for the new device into the project. The 20 kV level is to get one more outgoing feeder with the name Pullman Street that contains the same SIPROTEC 4 device as the outgoing feeder Pontomex Street. Take care of the necessary actions. All you have to do is copy the entire Pontomex Street folder. To do so, select it, keep the left mouse button pressed down, and pull it onto the 20 kV folder. Change the name of the folder copy to Pullman Street. Open the device in the Pontomex Street folder to edit it in the offline mode. Select the command Open Object from the device's pop-up menu. Alternatively, double-click on the device symbol. DIGSI 4 displays the dialog box Open Device. Select the offline option and click on OK. If all required data is loaded, the DIGSI device editor is displayed. For the following functions, select the settings stated next to them. 50, 51, definite time only. 50N, 51N, definite time only. Thermal overload protection without ambient temperature measurement. Breaker failure protection enabled. In the parameter area, right-click on Device Configuration and select Open Object from the pop-up menu. Alternatively, double-click on Device Configuration. In both cases, DIGSI 4 displays the dialog box Functional Scope. Each function has its own list field. With it, choose each of the necessary settings. Check your settings and click on OK. Set the following rated values of the outgoing feeder. Current transformer primary 150 ampere, secondary 1 ampere. Connection 3 times line ground voltage. Voltage transformer primary 20 kilovolts, secondary 100 volts. Connection 3-phase current transformer. Please note that the device calculates the ground current for the phase current transformer. For that reason, use the current transformer values given also for the transformer rated currents ground. Double-click on Power System Data 1. DIGSI 4 displays the dialog box of the same name. In the Power System tab, check the parameter VT connection 3-phase. This must have the setting VAN, VBN, VCN. In the CTs tab, enter the primary and secondary transformer rated current values. In the VTs tab, enter the primary and secondary transformer rated voltage values, then click OK. Parameterize the overcurrent protection in such a way that it only works single stage. Set the pickup threshold and the delay time of the first stage to 1.8 ampere and 0.3 seconds respectively. Double-click on Setting Group A. DIGSI 4 displays a dialog with which you choose a protection function in order to then parameterize it. Select the function name 50, 51 phase, ground overcurrent, and click on Settings. You will now see a further dialog box with which you can parameterize the selected protection function. Select the 50 tab and for the parameter 1202, enter the letter O twice. This letter combination means infinite and deactivates the high current stage of the overcurrent protection. In the same tab, now change the values for the threshold current and the delay time of the overcurrent level. then click on OK. Turn on the overload protection. Parameterize the time constant for heating up to 20 minutes and set the KT time factor for motor stop to 3. In the dialog box setting Group A, double-click on the function named Overload Protection. DIGSI-4 displays a further dialog box with which you can parameterize the overload protection. In the General tab, choose the setting On for the parameter overload protection. Switch to the 49 tab and change the value for the time constant to 20 minutes. So that you can set the KT time factor, mark the checkbox Display Further Parameters. DIGSI-4 then shows additional parameters and their settings. For the time factor, enter the value 3 and then click OK. Turn on the breaker failure protection. Parameterize the trip timer to 0.3 seconds. In the dialog box, setting Group A, double-click on the function named Breaker Failure Protection. DIGSI-4 once again opens a dialog box for parameterizing the selected protection function. In the General tab, choose the On setting for the parameter Breaker Failure Protection. Switch to the 50BF tab and change the value of the trip timer to 0.3 seconds. Then click on OK. Click on Close to hide the dialog box setting Group A. Set the capture time of the fault record that is started by an external signal to 1 second. Then save the entries that you've made up till now. Double-click on Oscillographic Fault Records. DIGSI-4 opens the dialog box of the same name. For the parameter Capture Time via binary input, enter the value 1, then click on OK. In the File menu, select the command Save, or as an alternative, click on the Storage Medium symbol in the toolbar. Remove all the routings on the binary input 1. Then route in such a way that the overload protection is blocked through a rising signal edge at binary input 1. Open the matrix by double-clicking on Masking I/O. With the right mouse button, click in the column BE1 and choose the command Delete all routings on binary input from the pop-up menu. With a double-click on the 49 Thermal Overload button, open the associated information group. Find the indication with the direct address 01503. With the right mouse button, click on the common cell of this indication and the column BE1 and choose Active with Voltage from the pop-up menu. Select the routed indication Block 49 Thermal Overload as binary track in the fault record. With the right mouse button, click on the indication's display text and choose the Properties entry from the pop-up menu. DIGSI-4 displays the dialog box Object Properties. In the Select in Fault Record tab, activate the checkbox Select Message in Fault Record, then click OK. The device is to output a signal to a free binary output as soon as the breaker failure is turned off. The signal is still to be active at the output when the breaker failure is turned on once more. With a double-click on the 50BF breaker failure button, open the associated information group. With the right mouse button, click on the common cell of the indication 50BF trip and, for example, the column BA1 and choose the setting Latched from the pop-up menu. In the File menu, select the command Save, or as an alternative, click on the Storage Medium symbol in the toolbar. Pressing the F1 key should cause the stored extreme values of the active power P, the apparent power S, and the reactive power Q to be reset. First of all, a user-defined information is necessary for this. As soon as you press the F1 key, this is sent and then further processed by a CFC function. This CFC function only consists in principle of one universal timer that makes sure that the indication exists for a defined time period. The timer's output is interconnected with the three indications P MIMA reset, S MIMA reset, and Q MIMA reset. As soon as one of these indications exists, the respective associated power value is reset. In the min-max meter group of the device matrix, insert a user-defined information of the type single-point indication. Name it res PSQ. Route the indication in such a way that it's available in the CFC as input information. As a result of the CFC function, the three indications PMIMA reset, SMIMA reset, and QMIMA reset should be sent. Also route these indications. With a double click on the min-max meter button, open the associated information group. From the View menu, select the entry Information Catalog, or as an alternative, click on the corresponding icon in the toolbar. In both cases, DIGSI-4 displays the Information Catalog. One after the other, open the folders Annunciations and Tagging. Select the information type Internal On/Off and drag it from the catalog into the group Min-Max Meter. In the Display Text column, enter the name Res PSQ. Exit the Information Catalog. With the right mouse button, click on the common cell of the indication Res PSQ and the column Destination C and choose Configured from the pop-up menu. With the right mouse button, click on the common cell of the indication PMIMA reset and the column Source C and choose Configured from the pop-up menu. In a similar manner, also route the indications SMIMA reset and QMIMA reset. Insert a CFC chart with the name PSQ reset and open it. In the parameter area, right-click on the entry CFC. In the pop-up menu, click on Insert CFC Chart. DIGSI-4 adds a new chart to the list view. Through the pop-up menu of this chart, open its Properties dialog. Replace the given standard name with PSQ Reset, then click OK. A double click on the chart name opens the chart so you can edit it in the CFC editor. In our example, the run sequence measurement processing is set when the chart is opened. Set the run sequence to PLC processing for this chart. With Edit Run Sequence, open the Runtime Editor. Select the Measurement Processing Execution level and drag the PSQ Reset folder onto the PLC Processing Execution level. In the Edit menu, once again select the entry Run Sequence to close the Runtime Editor. The CFC function consists solely of a short timer block. Insert this in the chart and parameterize its runtime to 1 second. In the block catalog, open the folder Time and Clock. Select the timer block and drag it from the catalog onto the chart. With the right mouse button, click on the block connection T and select the entry Object Properties from the pop-up menu. The CFC editor displays the Properties dialog. Enter the value of the required runtime in milliseconds, then click OK. Interconnect the input start of the timer block with the indication Res PSQ. Then interconnect the output QT With the three indications PMIMA reset, SMIMA reset, and QMIMA reset. With the right mouse button, click on the input Start and choose the entry Interconnection to Address from the pop-up menu. The CFC editor opens the dialog box Select Left Border. Select the indication Res PSQ and click OK. In the left border, the entry for the interconnected input information then appears. A connection line visualizes the interconnection between the information and input of the function block. With the right mouse button, click on the output QT and from the pop-up menu choose the entry Interconnection to Address. The CFC editor opens the dialog box Select Right Border. Select the indication PMIMA reset and click OK. The entry for the interconnected output information now appears in the right border. Here as well, a connection line visualizes the interconnection between the information and output of the function block. Similarly, also interconnect the indications SMIMA reset and QMIMA reset with the right border. Start the compilation of the chart, exit the CFC editor, and save your entries. Open the chart menu and select Compile Charts as Program. The CFC editor compiles the chart and lets you know about its progress. From the chart menu, choose the command Exit. The CFC editor is closed. From the File menu, select the command Save, or as an alternative, click on the storage medium symbol in the toolbar. Connect the PC and the SIPROTEC-4 device via an interface that is suitable for the initializing of the device. To connect the device and the PC, you need the serial cable that came with DIGSI-4, connected to a free serial interface on the PC. Connect the other end of the cable to the operating interface of the SIPROTEC-4 device. Initialize the connected SIPROTEC-4 device. Open the Pontomex Street folder and select the command Initialize Device from the pop-up menu of the device symbol. DIGSI-4 displays the dialog box of the same name. Select the identifier of the PC interface to which you've connected the connection cable to the device. For all other communication parameters, keep the standard settings, then click OK. With a click on OK, confirm that DIGSI-4 is to actually initialize the device. As a further protection measure, you must enter the current password for initializing. Establish a direct connection between DIGSI-4 and the device. In the Pontomex Street folder, double-click on the device symbol. DIGSI-4 displays the dialog box Open Device. Select the option Direct and click OK. DIGSI-4 sets up a connection to the device. Read out the device's event log and save it on the PC. In the tree view, open the Annunciations area and then click on Event Log. As a result, the list view shows an entry that consists of a date and a time. Double-click on this entry. DIGSI-4 reads out the event log and displays this in its own window. In the File menu, click on Save. DIGSI-4 then saves the displayed indications in a file. Close the Annunciations window. Trigger a test fault record, open it with SIGRA4 and then close it again. In the tree view, click on Test and then double-click in the list view on Test Waveform. The device now records a fault record. In the tree view, open the Oscillographic Records area and then click on Oscillographic Fault Records. The list view displays an entry for the generated fault record. Double-click it to display the fault record with SIGRA4. In order to close the fault record, select the command Close from the File menu. For the next tasks, please use the fault records line A and line B. You will find these fault records on the current DVD in the directory Pool Fault Records. First of all, open the fault record line A. Then add the fault record line B to the first one. From the File menu, select the command Open. SIGGRAPH4 opens a file selection dialog box. Select the fault record line A in the specified directory and click OK. SIGGRAPH4 opens the fault record and displays the sampling values as time signals. Open the Insert menu and click on Fault Record. Here as well, SIGGRAPH4 opens a file selection dialog. Select the fault record line B in the specified directory and click OK. SIGGRAPH4 adds the second fault record to the first one. Configure the network for the fault location using the following data: line length 45.6 kilometers, resistance value 65 milliohms per kilometer, reactance value 292 milliohms per kilometer. In the menu bar, click on Options and select Network Configuration. SIGGRAPH4 opens the dialog box Network Configuration. Choose the Fault Locator tab and enter the necessary values in the appropriate fields, then click OK. Start the Fault Locator. Select the Fault Locator view either via the menu or by clicking on the icon in the toolbar. SIGGRAPH4 calculates the fault location and displays this in picture and text.